When it comes to web applications, there is a need to transmit data between the client and the server. So for reading the data or for transmitting the data to the server, the data should be present in a structured format. So for this purpose, we use JSON, which is nothing but JavaScript object notation. Hello viewers, in this video, I'll be touching upon the JSON strings and how we can convert them to data frame and vice versa. Subscribe to my channel to get more alerts on videos related to Python and data science. So JSON actually uses an easy and readable format for structuring the data. So what it does is, it actually organizes the data in the form of property value or key value pairs. Let us consider the data frame that we were working on. So here I have got 6 columns containing integer, float, object and datetime data type. Now I want to convert this data frame to a JSON string. All that I have to do is to call the toJSON method. So I'll give dataframe.toJSON and pandas is going to give me the JSON string. So this is the JSON string that contains the data for all the columns and for all the rows of the data frame that we were working on. So we can observe that this data is now converted to a string. So in other words, the data is now serialized. So actually we'll come across two different terms which are nothing but serialize and deserialize. So serialization means the object, that is the data frame in our case, will be converted to a string. Deserialization is a process in which we convert a JSON string to an object, and in our case the JSON string will be converted to a data frame. So in this video we are going to look at both the processes, where I'll be walking you through the process of converting a data frame to a JSON string and vice versa. So in this JSON string we can observe that it is in a nested format with the column label acting as a primary index. So which means the string is created in such a way that it is going to query based on each and every column. So for column 1, what are the various row values, and then it will get the value for column 2 for the different row values, and that is how the JSON string gets generated. So we can see that column 1 colon, for the row label A it is 10, for B it is 20, for C 30, so it will go on till E, and then for column 2, what are the values of A, B, C, D, E? So the JSON string got generated till column 6. This is the default format where the orientation will be based on columns. I can also explicitly specify that by giving orient equal to columns. So this is the default value of the orientation and the output is going to look the same. Say for example, my requirement is to create a JSON string with the orientation on row labels and not based on column labels. So in that case, I can give orient equal to index, where I can get a JSON string created with the primary index as the row label, followed by the values of each and every column that is present in the data frame. So I have this nested format where for each row, which is for row A, I get the values of all the columns, and then for row B I have the values for all the columns, and similarly I have it for all the rows till row E. We also have other orientation methods to serialize the data. So if we go by records, I'll get the JSON string created for each and every record, and if it is for values, I'll have the JSON string created as a list of values. So all the default marker for the missing data will be converted to null. So that is why we are seeing null here in this JSON string. And the other orientation method is by giving the split, where I'll get the split of all the columns, all the indexes, and then I'll have all the data in the array format. So these are the various methods of creating the JSON string from the pandas data frame. So now let's get into the deserialization process, where I have a JSON string with me and I want to create a data frame out of it. So what I've done is, In my project, I've created a new file named sample.json where I've placed the first JSON string in that sample.json file, and I'm going to call this JSON file in my Python file. I can do that by calling the read_JSON method by passing the file name. So here I'm passing the file name, which is sample.json, and then I'm printing rd, which is going to return me the data in this format of data frame. When we compare the data types of the data frame before serialization and after deserialization, we can observe few changes in it. So before serialization, in my data frame, column 1, column 2 and column 4 were of integer type, column 3 was of float type, and column 5 of object type, and column 6 was of date type. But after deserialization, I can see that column 1, column 2 were of integer type, column 3, column 4 and column 6 were of float type, whereas the column 5 was retained the same. So column 4, which was initially an integer column, is now converted to a float. Column 6 was a datetime column, is now converted to a float. So due to this mismatch, we are seeing the data in a different format, and also there is a change in the default marker for the missing data. So we need to handle this mismatch in data type. One method to handle this is to provide the data type for each and every column during the deserialization process. So while reading the JSON file, I can specify the file name along with the data type of each and every column. Say column 1 it is integer, column 2 it is integer, and so on. So while printing the data frame, we can see that all the columns are in the format that we have mentioned, but we still see some change in the datetime column. That is, the data that was present initially in the data frame is not the same as what we have got from the JSON string. Though the type of the data frame is now corrected, we still see a mismatch in the datetime column. As per the API reference documentation provided by pandas, a column label is date-like if it ends with _80 or with _time, or it begins with timestamp, or it is modified, or it contains date. So I am going to create a datetime column with a label that matches one of these conditions. So instead of column 6, I've renamed the column to be date, and then I'm converting it to JSON. So the JSON format is going to look like this, where the date is in this particular format, and when I'm going to read that sample JSON, it is going to generate the data frame containing the correct date type. Now we can see that serialization and deserialization works perfectly fine. So when a JSON string is generated, the nan, nat and the none default marker will get converted to null in the JSON string during the serialization process. So there are some additional parameters that a data frame takes while serializing the object. So in my example that I was showing you, I was printing the JSON data in the output window. I can get that generated in a file as well by making use of the path or buffer parameter by providing the path name. So here in the to_JSON, I have given this additional parameter, which is path or buffer, where I have specified the location where this particular JSON file has to be generated. So I'm pointing it to the sample.json. So whenever I'm going to run this code, this sample.json file is going to be updated with the latest JSON string. When I give the path name directly, I'll get this syntax error due to the escape characters, which is the backslash that we have used here in the file path. So to fix this issue, Python gives us an option to treat a string as a raw string by giving r in either lowercase or in uppercase before the string. So here I'm using the lowercase r. When I execute the code, I can see that this error no longer comes in, and Python is going to consider this location as a literal string, and the JSON is going to get generated here. The other optional parameter that we have is the date format. So this format is going to tell us how the date should appear in the JSON string. It can hold the value of either epoch or ISO. So in this example, I'm going to give date format is equal to epoch. Actually, this is the default date format. So what exactly happens is this epoch will return a value that indicates the number of seconds that have elapsed since 1970-01-01. In the JSON file, we can see some number here. So this is going to be the time that is elapsed from that particular date. The other option that I have is the ISO format, which is going to return me the date that I have in my data frame. So I'll just give ISO, and I can see that the sample.json is going to hold the date in the ISO format. Date unit is another parameter that we can give while writing to a JSON file. So here I've given date unit to be seconds. So in my JSON file, it is going to contain value till seconds. So hours, minutes, and seconds. I can also give milliseconds, nanoseconds. So let me change it to milliseconds. So in my JSON file, I can see the date in the format till milliseconds. Thank you for watching this video. Hope you have got a clear picture about JSON IO tool using pandas.